Okay, this is the second part of section 7.3, so let's just jump right in. If sine of theta is 3 over 7 and theta is in the second quadrant, find cosine of theta. Okay, so they gave us sine of theta is 3 over 7, and we know that sine of theta is y over r, so what they're really saying is x is equal, or sorry, not x, y is equal to 3 and r is equal to 7. Now we're trying to find cosine of theta, which is x over r. I have y, I have r, but I don't have x. So I need to use the Pythagorean theorem to find x. So that would be r squared is equal to x squared plus y squared. Now I'm going to solve this for x. So I'm going to move y over. So I get r squared minus y squared is equal to x squared. And then I need to square root both sides. So that gives me x is equal to the square root of r squared minus y squared. And since I have those two numbers, I'm just going to plug and chug. So I've got 7 squared minus 3 squared. So that gives me 49 minus 9, which is square root of 40. Now I can break that up into 4 times 10, which I can break that up into the square root of 4 times the square root of 10. And we know that the square root of 4 is just 2, and then we're going to leave the square root of 10 alone. Okay, now I can just plug in what I know about x and r. I know that x is 2 square root of 10, and I know that r is 7. Now before you say, okay, this is my final answer, and you circle it, well, we also have this part right here. Theta is in the second quadrant. So if we use all students take calculus, and we're over here in the second quadrant, this is our theta, then only sine and its reciprocal cosecant are going to be positive. The rest of the trig functions, including cosine, will be negative. So this is actually negative. Now we can say that this is our final answer. Now this is the first way. Another way you could solve this is using the Pythagorean identity, which is cosine squared plus sine squared equal to 1. Now what they do here is they take what they know about sine, which is 3 over 7, and they square that number. So they square the 3 to get the 9 right here, and then they square the 7 to get the 49 on bottom. So they're just plugging the 3 over 7 into that formula, or that equation. Now what they do is they're going to move 9 over 49 to the other side, like this, and they take this 1, and they make that 49 over 49 minus 9 over 49, which gives them that 40 over 49 that you see right here. Now that's not going to be your final answer because that's cosine squared, and we just want cosine. So they need to square root both sides. So square root. And usually when you put the square root on an equation, you also need to add the plus or minus. I didn't do that here because I used all students take calculus to figure out what my sign should be for that trig function. But for this one, they put the plus and minus sign in front of the square root. And then there's an intermediate step, which I'll show you. They break up the square root into the square root of 40 over the square root of 49. Well, we know the square root of 40, we did back in the other problem, is 2 square root of 10, like you see right here. And then the square root of 49 is just 7, like you see right here. And notice they still have the plus or minus in front of our number. And then they go through the same process where they say, well, cosine is negative in the second quadrant, so therefore our final answer will be negative 2 square root of 10 over 7. Okay, if we switch to domain and range of sine and cosine, in the unit circle we know that x is cosine and y represents sine. And within the unit circle, we know that the radius is always 1. So if we go on the positive side of x, the maximum that it could be is 1. On the negative side of x, the maximum that it could be is negative 1. If we go to the maximum for y, that's going to be 1. The maximum for the negative side of y, that's going to be negative 1. So you know that that x can go between 1 and negative 1, and y can go between 1 and negative 1 as well. So, and it says that right here as well. The x-coordinate can go between negative 1 and 1, and so can y. So since x is cosine and y is sine, what that's saying is that sine and cosine, the output, so whatever angle that you put into sine or cosine, what you're going to get is a number between negative 1 and 1. And also, you can put any type or value of angle into cosine or sine. It can be negative, it can be positive, it can be any type of angle. If you plug that into cosine or sine, you're going to get something. It's going to return a result between negative 1 and 1. So because you can plug any angle that you can think of into these two functions, we say that the domain of sine and cosine is all real numbers, or basically anything that you want to put into those two functions. Another way of writing that, more mathy term of writing that, would be the interval between negative infinity to positive infinity. And go back right here. Range of sine and cosine goes between negative 1 and 1. That's just going to be your output. Okay? Reference angles. Now, reference angles, there's two things you need to know about this. A reference angle is always going to be an acute angle. So it's going to be between 0 and 90 if you're in degrees, or 0 and pi over 2 if you're talking about radians. And the way you form this, it's always between the terminal side of the angle and the horizontal axis. Okay, now put a star by this. Some students try to make the reference angle between the terminal side and the vertical axis. It doesn't work that way. It's got to be between the terminal side and the horizontal axis. Okay, so different quadrants, there's different formulas to find the reference angle. So in the first quadrant, and by the way, T prime, that's what we're calling our reference angle. T is just the angle that they give you. So if I've got, say, angle 60, well, the reference angle to angle 60 would just be 60. Notice here in this formula, T prime, the reference angle is equal to T, or the angle that they give you. So anything between or within that first quadrant, that they basically give you the reference angle. So the reference angle of 75 is 75. In quadrant 2, T prime is equal to pi minus T, or that's in radians, or 180 minus T. So if you notice, okay, so they're saying that this right here is the angle that they give you. What you want is this little bit right here. Now, if I go all the way to that point, that is 180. If I take away this little bit, which is the angle that they gave me, so I have all of this, and then I'm taking away just this little bit, which is leaving me with this little section right here. So that's what they're doing. 180 minus the angle they give you is leaving you with the reference angle. And notice how it's the horizontal axis right here and the terminal side. Same thing here. Horizontal axis, terminal side. Okay, in quadrant 3, your reference angle is equal to the angle they give you minus pi, or the angle they give you minus 180. And we can look at the same thing. If this is the angle they give you, okay, and this right here is 180. Well, notice that the angle that they give you is bigger than 180, so that one's going to go first. So it's between this one and this one, they're flipped between the 180 and the angle that they give you. So when you do the angle they give you minus 180, well, then you're left with this little piece right here, which is the reference angle. And again, your horizontal axis and your terminal side, that makes your reference angle. Last but not least, quadrant 4. Okay, reference angle is equal to 2 pi minus t, or the angle they give you, or 360 minus t, or the angle they give you. Okay, so they start with 360. So if I go all the way just around the circle, that's 360 right there. And then the angle they give you, say, is about here. Well, if I take 360 minus the angle that they give you, I'm left with this little piece right here. And notice that little piece is between the horizontal axis and the terminal side. So that's going to be our reference angle. Okay, so all of these formulas here for each quadrant, there's no really a nice trick to memorize them. You just have to memorize them. Okay, so if we apply that, so we are trying to find, let's see, we're trying to find the exact value of cosine of 150, and we can do that using reference angles. So 150 is in the second quadrant, so here's our 150 angle right here, or sorry, went a little too far. Right there. Okay, there's our 150 angle. Now since we're in the second quadrant, notice we are looking at this formula right here. So we're going to do 180 minus the angle they give us, which gives us 30, which, since we're trying to find the exact value of cosine 150, if they were just looking for the reference angle to 150, then 30 would be our final answer. But since we're finding the exact value of cosine of 150, well, now I need to use the 30, 60, 90 triangle to figure out what is the exact value. Okay, so if it's 30 right here, then straight across from 30 is 1, which means this is 60. Straight across from 60 is square root of 3. Since we're on the negative side of x, that's going to be negative square root of 3. And within the 30, 60, 90 triangle, the hypotenuse or radius is going to be 2. Now we know that cosine of theta is x over r. Our x here is negative square root of 3, and our r is 2. So our final answer will be negative square root of 3 over 2. Okay, if we do the same thing, and then we're really just looking for sine of 150. So same thing, we're in the second quadrant, so we're going to do 180 minus 150. We get 30. If they were just looking for the reference angle, that would be our final answer right there is 30. But since they're saying, well, we want the exact value of sine of 150, well, then we need to take that 30 and apply the 30, 60, 90 triangle. Use that to find sine of 150. Now we know that sine of theta is y over r. Y is 1 and r is 2. So sine of 150 is 1/2. You can also kind of check yourself to make sure, well, do I have the right sign? Say you accidentally put a negative right there. Well, use all students take calculus. We're in the second quadrant. Whoops. The second quadrant, so that means sine should be positive. So when you end up with a negative 1 over 2 and you say, well, sine should be positive there, you can say, oh, that should be positive and take that away. Same thing over here. Cosine should be negative in the second quadrant, and that's what we're getting. Okay, so that's kind of like a check mark just to make sure you've got the sign right.